Hello, this is Miss Weiss, your math teacher, and today we're going to be looking at functions. So you're going to need out that note sheet I gave you and take notes as I'm going through this. So a function is just a rule that assigns each input element x, so x is your input element, with exactly one output element, f of x. So f of x is what comes out of it. Usually we use y as well, but right now we're doing function notation, so we're using f of x as our output. So basically with any function here, the x's cannot repeat for it to be a function. So let's just look at an example of this. So if I have these ordered pairs, 1, 2, 2, 3, 3, 4. So looking at those ordered pairs, each input value can be assigned with exactly one output value. So this 1's not assigned with any other value except 2. This 2 is not assigned with any other value, just a 3, and this 3 is only assigned with one value, it's just 4. So the x's do not repeat. There's 1, 2, and 3. There's not another 1 something or another 2 something or another 3 something. So yes, this is a function. You can also tell graphing wise, you could just go ahead and plot these on a nice little graph here. So if I graph that out, I've got 1, 2, 2, 3, and I've got 3, 4. And if it makes any part of a vertical line here, then we know it is not a function. If I put my pencil through any point here, and I try to go through two of them, these two will just draw a nice line through this. It's going to make a diagonal line, not a vertical line. A vertical line goes up and down. So a vertical line's not going to go through any 2 points on that graph there. So it is a function as well with graphing wise. So I'm going to go to my next one here, and these are just going to, we're going to look at some examples of what a function are. So what functions are. So this one here, I'm looking at these 1, 2, 1, 3, 1, 4, and 1, 5. So looking at these, I can tell that it is not a function because I'm looking right away saying, oh, 1 is paired with 2, 1 is paired with 3, and 1 is paired with 4, and 1 is paired with 5. So definitely the x's are repeating there. So no, and I'm supposed to explain why, and I'm going to say because the x's repeat. So again, don't forget you're taking notes on these. And so let's go on to another example of this. So is this a function? So kind of looking at my x's here, they're unique here. They're not repeating. There's a 1, 7, but there's not like a 1, 6 there. So also with that, so I know that yes, it's a function. And again, I don't have to explain this. I was going to say x's do not repeat, but I can just say yes, it's a function. I don't have to explain if it's a yes. So looking at our next example here, and our last one here, we've got 1, 2, 2, 2, 3, 2, and 4, 2. So again, just looking at your x's here, noticing your x's are not repeating, so yes, this is a function, and you could move on. The other thing, again, like I said before, you could graph this out. Um, so graphing this out, I got 1, 2, 2, 2, I've got 3, 2, and I've got 4, 2. So notice again, if I put my pen through these lines here, and if I connect those, I'm going to make a horizontal line which goes from left to right, not a vertical line that goes up and down. So this passes the vertical line test, so therefore it is a function there. It's not, two of these aren't straight up and down from each other, so it is a function. So now we've done the first part of our objective here. We went ahead and figured out whether something was a function. Our next part here is another objective is to try to figure out if we can put this in function notation. So we want to be able to write this in function notation. With function notation, remember you have an f of x and you have an x in it. So let's write our function notation. So I'm going to say f of x equals, and whatever they're telling us to do that, we're doing that to the x there. So it says to go ahead and square. So we're going to square the x. And then we're supposed to add 9 to that. So we end up getting x squared plus 9. So we squared the x, and then we just added 9 to it. Part B there says to go ahead and multiply by 2 and then subtract 3. So looking at one like this, I'm going to use my function notation here. So I've got f of x equals, I'm going to multiply my x by 2, and I always put the number first and then the x there, the variable there second. And then I'm supposed to subtract 3. So in other words, with this one, I wouldn't write x2 minus 3. I would do 2x minus 3. And then my third example here says to add 3 and then take the square root. So again, using my function notation, f of x equals, I'm going to add 3 to the x, so x plus 3. And then I'm supposed to take the square root of that result. So if I'm going to take the square root of the result, I'm going to put square root over the entire thing. So the square root of x plus 3. So far we've figured out what a function was. We've written it in function notation. And we're going to get started with probably just one example of completing a table here. Actually, we'll get through, well, we'll see if we can get through two. But let's see if we can get through one here first. So completing the table here. So you have tables on your note sheet there. I'm going to make one that looks similar to yours. You have some x values here. I'm going to put in the same x values as what you have. And I'm going to plug those into my function here. So this is telling you now to take this input value of your x and plug it into your function and then see what your output value, your f of x is, what value that is. So I'm going to take -2 and I'm going to put it in here for the x. So it goes 3 times -2 minus 2. And when I'm doing this, I gotta kind of think through what I'm supposed to do here. We've got 3 next to the x, that means multiplication. And of course, you have to subtract 2. And then the last thing I'm going to do is what these little brackets here on the outside look like. They're actually called absolute value symbols here. So we want to solve everything inside here first. So I'm going to do that first. So 3 times -2 here is -6 minus 2. And -6 minus 2 there just gives me a result of -8. But I still have to take the absolute value. That's what these two little lines there on the outside. Absolute value is this distance from 0 on a number line. So if you think about how far -8 from 0 is on a number line, -8 is a distance of 8. So we always think of distance as being a positive value. That's why whatever comes out of the absolute value has to be positive, because we're thinking about distance on a number line. So -8 would be 8 from 0 on a number line, and 8 would be 8 on a number line. So both the absolute value of -8 and the absolute value of 8 both have a result of 8. So coming over here, I'm going to put my value down there of 8. Now my next one here, I've got 3 times -1 minus 2. 3 times -1 gives me -3. And then I can go ahead and subtract 2, and I get -5. And then I can go ahead and take the absolute value of -5. Now -5 is 5, has a distance of 5 on the number line. So my value over here is going to be 5. And then my next one here, we've got 0 we're going to plug in there for our x. So again, putting 0 up here and for our x. So doing that, 3 times 0 minus 2. So 3 times 0 there is 0. Minus 2 there is -2. And then I have to take the absolute value of that. And that's -2 has a distance of 2 on the number line from 0. All right, and then don't forget, if you're not comfortable with absolute value or doing some of this math, you can always do it on your calculator. So if you got the TI-83 or TI-84, you've got nice absolute value symbols on there. So you can always plug those in there as well. If I did that, I could find my absolute value key on there. I could hit the math button and then go over to use my right arrow and go over to num there at the top. And then there's an ABS key, and I'm going to hit enter. And then inside there, I'm going to punch in 3 parenthesis 1 end parenthesis So I'm going to do the same thing here. Minus 2, end parenthesis. So I'm plugging this into my calculator. And then I'm going to use my right arrow key and go over the absolute value symbol there. I'm going to hit enter, and I end up getting 1. So I'll do the math over here as well. So we get a value there of 1. So again, I could do another one of these. I could go 3 times 2 minus 2. So inside here I get 6 minus 2, and I get the absolute value of 4, and the absolute value of 4 has, from 0 on the number line, has a distance of 4, so my end result there is going to be 4. So doing that, we can also plug that into the calculator. So again, I could go math, use my right arrow, go over to num. There's ABS right at the top there. I'm going to hit enter. And then my absolute value symbols come on the screen, or some of you, if you got to 83, you're going to still say ABS, but that's fine. And then I'm going to plug in 3 parenthesis 2 parenthesis minus 2. I'm going to use my right arrow key to go on the other side of the absolute value symbol there, and I get a value of 4. So 2 different ways of being able to do that. You can plug it right in your calculator like it is, or you can write it out and solve it as you go. It's up to you. So we're gonna stop there and give you some work to do with that. So now you've got your quiz to take on Schoology as well. So let's just go ahead now and instead of doing that quiz, let's just go ahead and do the 2-1 worksheet, numbers 1 through 4 and number 12. If you could finish those up, that would be great.